Chapter 12 Organic Chemistry. Some basic principles and techniques. Organic compounds are the hydrocarbons and the derivatives, and organic chemistry is the branch of chemistry that deals with the study of these compounds. Tetravalency of carbon. The atomic number of carbon is 6 and its electronic configuration is 2, 4, i.e. it has 4 valence electrons. Thus carbon is always tetracovalent, i.e. it forms 4 covalent bonds with other atoms. Due to tetravalency of carbon it has a tetrahedron shape. Catenation. The self-linking property of carbon is known as catenation. This is the main reason of existence of such large number of compounds. Classification of organic compounds. Organic compounds: acyclic, cyclic, homocyclic, heterocyclic, alicyclic, aromatic, benzenoid, non-benzenoid. Functional groups. A functional group may be defined as an atom or a group of atoms present in a molecule which largely determines the chemical properties. Class of organic. Name of functional structure. Compounds group. Alkenes double bond equals C equals C equals alkenes triple bond C C. Halogens halogen X F Cl bridge I. Alcohols hydroxyl O. Aldehydes aldehydic formal CHO. Carboxylic acids carboxyl CHO acid amides amides CONH2 primary amines amino NH2 material downloaded from SUPERCOP 1/16. Homologous series. Homologous series is defined as a family or group of structurally similar organic compounds, all members of which contain the same functional group, show a gradation in physical and similarity in chemical properties, and any two adjacent members of which differ by CH2 group. The individual members of this group are called homologs, and the phenomenon is called homology. Nomenclature of organic compounds. Organic chemistry deals with millions of compounds. In order to clearly identify them, a systematic method of naming known as IUPAC system of nomenclature is adopted. The names are such that the listener can deduce the structure from it. The IUPAC name consists of 3 parts: prefix, word, root, suffix x. 3-methyoctane. Nomenclature of alkanes. Straight chain alkanes. The names of such compounds is based on their chain structure, and end with suffix ane, and carry a prefix indicating the number of carbon atoms present in the chain. Branched chain hydrocarbons. 1. The longest carbon chain in the molecule is identified. 2. The numbering is done in such a way that the branched carbon atoms get the lowest possible value. 3. The names of the alkyl groups attached as a branch are then prefixed to the name of the parent alkane, and its position is indicated by numbers. 4. The lower number is given to the first in alphabetical order. 5. The carbon atom of the branch that attaches to the root alkane is numbered 1. Organic compounds having functional groups. The longest chain of carbon atoms containing the functional groups is numbered in such a way that the functional group attached to the carbon atom gets the lowest possible number in the chain. When there are more functional groups, then a priority order is followed as COOH, SO3H, COOR, COCl, CONH2, CN, HC equals O, equals C equals O, O, NH2, equals C equals C equals C. Isomerism. 2 or more compounds having the same molecular formula but different physical and chemical properties are called isomers, and this phenomenon is called isomerism. Material downloaded from SUPERCOP 2/16. Chain isomerism. When 2 or more compounds having same molecular formula but different carbon skeletons are referred to as chain isomers. Position isomerism. Compounds which have the same structure of carbon chain but differ in position of double or triple bonds or functional group are called position isomers, and this phenomenon is called position isomerism. E.g. CH3CH2CH equals CH2CH3CH equals CH3 functional isomerism. Compounds which have the same molecular formula but different functional group are called functional isomers, and this phenomenon is called functional isomerism. E.g. CH3CH2OCH3O, CH3 metamerism. It is due to the presence of different alkyl groups on either side of functional group in the molecule. X. C4H10O represents C2H5OC2H5 and CH3OC3H7. Fission of covalent bond heterolytic cleavage. In this cleavage, the bond breaks in such a way that the shared pair of electron remains with one of the fragments. H3C. Bridge plus CH3 plus bridge homolytic cleavage. In this cleavage, the shared pair of electron goes with each of the bonded atom. R. XR plus X. Alkyl-free radical nucleophiles. A reagent that brings an electron pair is called nucleophile, i.e. nucleus-seeking UGO, CN electrophiles. A reagent that takes away electron pair is called electrophile, i.e. electron-seeking UG greater than C equals O. R3C. X inductive effect. The displacement of the electron along the chain of the carbon atoms due to presence of an atom or group at the end of the chain. Material downloaded from SUPERCOP 3/16. Plus CH3CH2CH2Cl resonance effect. The polarity produced in the molecule by the interaction of two pi bonds or between a pi bond and lone pair of electron present on an adjacent atom. There are two types of resonance effect. 1. Positive resonance effect. In this effect, the transfer of electrons is away from an atom or substituent group attached to the conjugated system. The atoms or groups which shows plus R effect to halogens, O, OR, NH22, negative resonance effect. In this effect, the transfer of electrons is towards the atom or substituent group attached to the conjugated system. The atoms or groups which shows R effect to COOH, CHO, CN methods of purification of organic compounds, sublimation. This method is used to separate the sublimable compounds from non-sublimable compounds. Crystallization. This method is based on the difference in the solubilities of compound and impurities in a suitable solvent. The impure compound is dissolved in solvent heated at higher temp. On cooling, the hot and conc solution pure compounds crystallizes out. Distillation. This method is used to separate volatile liquids from non-volatile liquids and liquids having sufficient difference in their boiling points. Fractional distillation. If the boiling points of two liquids is not much, they are separated by this method. Distillation under reduced pressure. This method is used to purify liquids having high boiling points and decomposes at or below their boiling points. Steam distillation. This method is used to separate substances which are steam volatile and are immiscible with water. Differential extraction. When an organic compound is present in an aqueous medium, it is separated by shaking it with organic solvent in which it is more soluble than in water. The aqueous solution is mixed with organic solvent in a separating funnel and shaken for some time and then allowed to stand for some time. When organic solvent and water form two separate layers, the lower layer is run out by opening the tap of funnel and organic layer is separated. The process is repeated several times and pure organic compound is separated. Chromatography. This technique is used to separate mixtures into their components, purify the compounds and test the purity of compounds. It is classified as material downloaded from SUPERCOP 4/16. Quantitative analysis. Carbon and hydrogen. Let the mass of organic compound be mg. Mass of water and carbon dioxide produced be m1 and m2 grams respectively. Percent of carbon equals 12x m2x 144x m. Percent of hydrogen equals 2x m1x 118x m. Nitrogen Dumas method. A known mass of organic compound is heated with excessive CuO in an atmosphere of CO2, when nitrogen of the organic compound is converted into N2 gas. The volume of N2 thus obtained is converted into STP and the percentage of nitrogen determined by applying the equation. Volume of nitrogen at STP equals P1V1x 273,760 x T1% N equals 28x. Volume of N2 at STP x 100, 22400 x. Mass of the substance taken. Kjeldahl's method. A known mass of organic compound is heated with conc. H2SO4 in presence of K2SO4 and little QSO4 or Hg in a long-necked flask called Kjeldahl's flask. When nitrogen present in the organic compound is quantitatively converted into NH4, 2SO4. NH4, 2SO4 thus obtained is boiled with excess of no solution to liberate NH3 gas, which is absorbed in a known excess of a standard acid such as H2SO4 or HCl. The volume of acid unused is found by titration against a standard alkali solution. From the volume of the acid used, the percentage of nitrogen is determined by applying the equation, %N equals 1.4x molarity of the acid x basicity of the acid x volume of the acid used mass of the substance taken. Halogen's Carius method. A known mass of an organic compound is heated with fuming nitric acid in the presence of silver nitrate contained in a hard glass test tube known as Carius tube in a furnace. Carbon and hydrogen present in the compound are oxidized to carbon dioxide and water. The halogen present forms the corresponding silver halide. It is filtered, dried, and weighed. Material downloaded from SUPERCOP 6/16. Let the mass of the organic compound taken equals mg mass of AgX formed equals m1 gram. 1 mole of AgX contains 1 mole of X mass of halogen in m1 gram of AgX equals at mass of XX m1 gram molecular mass of AgX percent of halogen equals at mass of XX m1 gram by 100% molecular mass of AgX x m sulfur. Let the mass of the organic compound taken equals mg mass of BaSO4 formed equals m1 gram percent of sulfur equals 32x m1 by 100% 233x m phosphorus. Let the mass of the organic compound taken equals mg mass of ammonium phosphomolydate equals m1 gram percent of phosphorus equals 31x m1 by 100% 1877x m oxygen. Let the mass of the organic compound taken equals mg mass of CO2 equals m1 gram percent of oxygen equals 32x m1 by 100% 44x m1. Mark questions Q1 suggest a method to purify a liquid which decomposes at its boiling point. A1 The process distillation under reduced pressure is used to purify a liquid which decomposes at its boiling point. Q2 How will you separate a mixture of O-nitrophenol and P-nitrophenol? Material downloaded from SUPERCOP 7/16. A2O-nitrophenol is steam volatile, therefore it can be separated by steam distillation. Q3 Larsane's test is not shown by diazonium salt. Why? A3 On heating diazonium salts loses nitrogen and could not fuse with the sodium metal, therefore diazonium salt do not show positive Larsane's test for nitrogen. Q4 Alcohols are weaker acids than water. Why? A4 The alkyl group in alcohols has plus I effect due to which electron density is increases on oxygen.